Hey everybody, I hope you guys are doing well. We're going to look at geometric sequences. And let's start with quick definition. So what is a geometric sequence? Well, make sure you have this down. A geometric sequence is a sequence where the first term is non-zero, so it can't be a zero, the first term. And each term after that is found by multiplying the previous term by a common factor. So make sure you have that down. And I'll show you something in just a second that'll hopefully make this definition make sense with geometric sequences. So we started off sequences by talking about arithmetic sequences. And so what's the difference? What's the difference between an arithmetic sequence and a geometric sequence? Well, let's check that out. You've got a definition down. When we did arithmetic sequences, and we've got an example right over there, that 1, 8, 5, 22, 29, that sequence could continue, ... Basically, for the arithmetic sequence, well, let me pull up a geometric sequence and maybe you can check it out from there. So, if the arithmetic sequence is to the left, geometric to the right, the 2, 4, 8, 16, 32, what difference are you seeing between these two sequences? How are they going up? What are you observing there? Well, hopefully you're seeing with the arithmetic sequence we talked about, everything's kind of going up by the same number. 1 to 8, we're going up by 7 there. That's kind of a plus 7. 7 to 15 is another plus 7. 15 to 22 is another plus 7. So on and so forth. We're adding 7 each time. Well, if I go over to the geometric sequence, it starts, we've got a 2 to 4, which would seem to be like plus 2, but then if I go from 4 to 8, I'm not adding 2 there. It looks like maybe actually we're multiplying. So rather than adding, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and 16 times 2 is 32. So as it continues, we're multiplying with the geometric sequence. So arithmetic sequence, basically you're adding or subtracting, and geometric sequence, we're multiplying. And if it ever gets lower, we're just multiplying by a fraction. Okay. All right. So let's write. There's a way we can write basically to an nth term, and we're going to start with that. Kind of write an equation, and then we'll solve a little bit. So this says write an equation for the nth term. It's n like this, like n with a th at the top. Nth term. Don't worry, it'll make sense in a second. Write an equation for the nth term of the sequence. Okay. What's the sequence? We've got 2, 4, 8, 16, and 32. All right. Well, here's what we're going to use as our formula. And you have it down, but let's write down real quick what this formula means. Okay. So we've got a to the n equals a to the 1, and it's got times r, n minus 1. Well, here's what we're really saying with this. A to the n is a sub n, a sub n, a sub, S-U-B, which means we're substituting n kind of in this bottom value here. And that's your nth term right over here. So let's just go ahead and define that real quick as our nth term. Okay. And next up, you've got this a sub 1 with a 1 at the bottom of it right there. Well, we did this with arithmetic sequences. This is going to be your first term. So I'm just going to write it in right here. You can put a number, just a number 1 and write term if you want, but I'm going to write first term. Your first term would go there. And then the r, if we check out the r right over there, that also is something that we use with arithmetic, and that's going to be the common ratio that we find in our sequence. Okay, so make sure you have these down real quick, jot them down quick, trying to make it short and sweet, and then we'll go ahead and plug this in. Okay, all right, so let's use this sequence right here and figure out what the nth term is. When you see nth term, basically all we're really wanting to do is write the equation. Okay, so that's all we want to do when we see nth term. All right, so let's fill it in. So for the nth term, I've got still the a sub n is going to stay as it is, equals a1 is the first term. All right, so the first term is a 2, so I'm going to put a 2 in there. We're going to multiply it by the common ratio. What is the common ratio? Well, we need to figure out basically what's happening each time. I think we already kind of did this. 2 times 2 is 4, 4 times 2 is 8. So we're multiplying by 2 each time. So the common ratio is a 2, and then we're just going to have n minus 1. And that's really all we need when we write the nth term. We don't need to solve anything. That's basically the equation form of it right over there. And we're good to go. That's the equation form, or that's how we would write the nth term. Okay, let's try another one. All right, now on this one I've got this sequence 2, 6, 18, 54, and again we're writing an equation for the nth term. So let's start it out. I've already got the equation down for you. So a sub n is equal to the first term is a 2 right over there. So I'm going to put a 2 times the common ratio. Let's figure out the common ratio real quick. Let me switch over to green. All right, we're doing 2 to 6. Okay, we're multiplying. So remember, make a smaller arrow there. 2 times 3 is 6. Let's see if that continues. Yeah, 6 times 3 is 18, and 18 times 3 would be 54. So if we're continuing this sequence here, we're multiplying by 3. So let's throw a 3 in here as our common ratio, and then we just keep the n minus 1 for right now. We're not solving for a particular term just yet. We're just writing to the nth term. So if you're asked to write the nth term, you are basically writing, what do we say again? The equation, essentially, for the sequence. Okay, that's all we're doing when we do the nth term. All right, well, let's go beyond that. What if you get something like this? Get a geometric sequence and it says calculate a specific term, like the 12th term of the sequence, and that's what we're going to do here. So I've got this familiar sequence. We've already been working with it a little bit, 2, 6, 18, 54. All right, let's utilize this, and I've got our formula in there. Let's go ahead and we can write this, but then we can solve for this 12th term right here, and I can show you how to do that. You're going to need a calculator, okay? On this one, geometric sequences, because we're multiplying, we get to some high numbers and exponents, and you're definitely going to need your calculator. I've got mine by my side right here, okay? All right, let's start filling this in. So we're first going to write out the nth term, or the equation. So a to the nth term is going to equal the first term, which is 2. Write that in, times the common ratio. Well, the common ratio, I think, is times 3. We already figured this out one previously. We're multiplying by 3 there. I'll put like the times sign messily right there. 6 times 3 is 18, so that continues. So let's put 3, and then we've got my our n minus 1. Okay, so that's the first part. That's essentially the nth term. But we want to solve for the 12th. We're trying to figure out, hey, if this sequence continues and we go to the 12th term, remember, the 12th term means this real quick. Let me clarify. The 2 is the first term. The 6 would be the second, the third, the fourth. We want to figure out what the 12th term is, kind of trying to solve a mystery here, okay? All right, well, let's do that. I'm going to box this in just so we understand that this is our nth term, and then we're going to start filling in. So when we want to solve for the 12th term, we're going to say a in a neater fashion. We're going to say a to the 12th, a sub 12 is what we're going to say. So we're a substitute 12, essentially, is going to be equal to, we have our 2 times our common ratio, which is going to be 3. And now we've got n minus 1. Well, we've got the n. The n is going to be 12 again. And we're going to do 12 minus 1. Okay, let me show you how this works out. Okay, let's start simplifying. So a sub 12 in here is not going to change. It's going to kind of stay like that. It's going to equal, now 2 times 3, we cannot do that yet because we've got an exponent in play. Okay, we've got this exponent over here at 12 minus 1. We've got to kind of work that out first before we multiply our regular values down here. So we're going to do that 12 minus 1. That's pretty basic. That's 11. 12 minus 1 is 11. So what we really need to do now is we need to do this part where to do our next step, we need to do 3 to the 11th power, and then we'll multiply it by 2 to get kind of our final answer. Well, this is where I told you that calculator is going to be super handy, because 3 to the 11th power could take you all day trying to figure that out. So let's go ahead and plug it in. So I'm going to start writing this in. We're going to go a to the 12th power equals 2 times Now let's do 3 to the 11th power. On your calculator, I don't have a way to show it, but you're going to type in 3, and then you're going to look for a key that has an x with a little exponent y. So you're going to look for an x with a little exponent y, and you're going to hit that after you hit the 3. So you hit 3, you hit the x exponent y, and then we're raising it to the 11th power, so you type in 11, and you hit equals. Okay, so again, hit 3, find this button right over here, x to the y, and after you hit that, type in the 11, because we're raising this to the 11th power, and you should get this number right over here. You should get 177,147. I told you it's going to be a big number. And to finish out, all we need to do now is multiply that number times 2. And again, this is calculator work, okay? We're just going to take that answer, 177,147, hit times 2, hit equals, and the answer I'm getting is 354,294 as a final answer. This is the 12th term. So if we continued all the way, remember, dot, dot, dot to the 12th term, this would be that number right over here. It's a large number, okay? Let's try another one. All right, calculate the 5th term, all right? Let me move a little bit faster here. So we're first going to just plug everything in, all right? So let's do it real quick. A to the nth power. By the way, our number, 2, 14, 98, it continues, all right? So let's start with our first value. It's 2. 2 again. We had a lot of 2's in there. All right, good. Times. Let's find the common ratio. What's the common ratio? Well, this probably gives it out. 2 gives it up. I'm sorry. 2 times what is 14? It's 7. And I'll help you out here. 14 times 7 also gets you 98. So it's going to be 7. And then we have n minus 1. All right. Awesome. Sounds good. That is the nth term. Now let's solve for the 5th term in the sequence. Okay, let's do that real quick. So it's a sub 5 equals 2 times the 7 here. Over here I've got the, sorry, my a sub 5 doesn't look great. I'm going to fix that. I'm going to put it in purple too. So there we go. And then n minus, well, it's going to be 5 minus 1. Remember, that's our n value, okay? All right, let's start solving and make sure you got that calculator handy. A to the 5th power, we're going to do 2 times 7 in a second, but let's do 5 minus 1 there, which is 4. And now we can start utilizing the calculator. So a sub 5 equals 2 times, we need 7 to the 4th power. So again, to your calculator you go. You hit 7. You hit that x to the little exponent y button right there. You hit the number 4 because we're raising it to the 4th power. You hit equals, and you get a number that should be 2,401. So we're going to multiply times 2,400. Very not neat. Apologize. 2,401. And then just multiply that times 2. Hit times 2. And it's going to be 4,802 as a final answer. So a sub 5, the 5th term in the equation is going to be 4,802, and we're good to go. All right. All right. One last example. I just want to do one real quick where your sequence is decreasing, just to give you an example real fast. We've done well so far. Check out this sequence. I've got 1,536, and then it goes to 768, 384. And dot, 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 it continues, it continues, it continues. Let me shrink down this a little bit, bring it up, give us some space. All right, cool. We've got the formula down. Let's go ahead and write this in the nth term value real quick. A sub n equals, first term is a big one, 1536. So let's write that in, 1536. And again, calculator. On the geometric sequences, you want to have the calculator. With the arithmetic ones, we didn't necessarily need them all the time, but geometric, you're going to want to have them. Okay. So 1536 times the common ratio. So what's happening here? Well, probably figured it out from here to here, and I'm writing this kind of messily, but really, we're halving our value each time. So what do you multiply by? We're multiplying by 1/2, okay? So I'm going to write that down here. I'll take away those little arrows at the top, but we're essentially multiplying by 1/2 each time, and then that is n minus 1. Okay, so this right over here is our nth term. We're good to go. That's awesome. We want to calculate, though, the 8th term of this sequence. It's going to continue to decrease and half, so let's figure out what the 8th term will be. All right, cool. We know how to do that now. Let's do a sub n equals 1536. Awesome. Times. Now we've got a, well, a sub n, I should have probably put in the 8 there. Apologize for that. A to the sub 8, because that's what we're solving for. And then let's do 1/2. And then here we have 8 minus 1, because that's what we're solving for, the 8 minus 1. All right, let's start going across here and make sure you got the calculator ready. Okay, a sub 8 is going to equal 1536 times 1/2 to the 7th power. Okay, so I'm just going to real quick to make this easy. We know 8 minus 1 is 7. So let's do 1/2 to the 7th power on your calculator. So 1/2, do 0.5, 0.5, hit that X to the Y button, find that real quick, and then that's to the 7th power. And I think you get like something kind of small. It should be a sub 8. A sub 8 equals 1536 times, and the number I'm getting is like 0.00781, and it kind of continues. Okay, all we want to do is multiply that number times 1536. So do that real quick. Hit times 1536. Hit equals, and you should get, if you typed it all in correctly, you should get, actually, you're probably not sure how you got this, but you got 12. Even number 12, it works all the way out to just 12. So the 8th term in this, if it kept decreasing, would be 12. All right. So excellent job. This is geometric sequences.